the welcoming remarks and opening remarks, even as he hands over the program back to AWS. Welcome, Dr. Rotich. Tumpatie some heavy. Thank you.
Good morning, everybody. Yes, I'm so happy to be here again for the third AWS Community Day. I think it's been a journey. We started a while back in 2022. Now we're in 2025. We are looking forward to hosting another one in 2026, 2027, up to 2050. So we'll be here. Every year we'll be hosting the AWS Community Day. I want to welcome this is a very important day, and you know, here in Kenya it's a big day to have a vice president in our attendance. The vice president of Amazon Group, the big group, the big tech organization. Feel welcome, Karibu to Kenya, the land of wildlife and athletes. You know, we are the ones who win. We are the only country which wins marathons around the world. But soon, we'll be competing with the US and others in terms of technology. You've heard that this is a Silicon Savannah, so we are coming up very well. And I think events like this take us a step forward in terms of nurturing the talent that we require to power this country in the years ahead. To the people who are here, I want to thank Silicon Overdrive, who have been our partner in this journey, especially this year. I want to thank Valisa for getting into a plane all the way from South Africa up to this place. You know, and take it for granted. And I keep forgetting your name. You know, last year you gave a very good speech last year here. Yes, Robin. Yeah, yes, and of course the Cloud Queen and all the visitors who have come today. Feel welcome. I'm looking at these events like this, not just as a catering of people or just education, but should be the dissemination point for innovative ideas that's going to change the way we do things in this country and the way we develop new products and solutions for this particular country. You know, Kenya, most of you here, most of you are Kenyans. In Kenya in 1963, somebody stood up, the first Prime Minister of Kenya, who later became the President, Jomo Kenyatta, said that we have three enemies: poverty, disease, and ignorance, okay? That was in 1963. In 2025, we still have those particular enemies again. We have not even been able to defeat even a single one of them. So I think young people now, like the ones who are seeing in the room now here, the Gen Z who are here in the room, I think now we are passing the baton to you, yeah, so that you can be able to take on these enemies in a very decisive manner, the way you did last year. You know what you did last year. I don't want to say what you did last year. Yeah, but I think this is a very good event. On behalf of the Vice Chancellor, I want to assure you that KCA is ready and willing to work with Amazon Web Services, not just today, but in the years to come. And like we said, we told the Cloud Queen here in 2022 when she came, that Amazon doesn't need to go and host their events in a hotel. This is their home, because the university belongs to the community. Otherwise, it would be an elitist organization serving vested interests. We are here to serve the community. So feel welcome and have a good education day. And I hope to see you again next year, 2026, at a time like this. Thank you very much, and welcome to KCA.
My name is Kevin Tuei. I'm a cloud technology consultant at SolarVis Technologies, as well as the AWS AIML user group leader, the only specialized AWS AIML user group in the whole of Africa. Ladies and gentlemen, we'd like to welcome you, the CTO and the VP for Amazon, Dr. Werner Vogels.
Hamjambo. Yeah. So thank you for coming here. By the way, you are the real stars here. Two things, so just getting screens and printers to work. Why after 15 years, 50 years, we haven't solved that one yet, is it? So I want to take you back a little bit in time. It's now almost 20 years ago that we launched AWS. Yeah, but there was a time before that, before cloud. I know maybe many of you have never known a time without cloud, but there was something, definitely in my history, there was a time before cloud. And as the CTO of Amazon, a massively big scaling operation, you had to always think very hard about how much capacity you needed to serve your customers. Because, you know, it's also on a cyclic during a weekly period, you know, there's the highs and lows. But we become really good at sort of predicting what we would think next year's traffic would be. And as such, you know, I could start buying hardware ahead of time. But one of the things was that if I would be a little bit too positive about what I think next year's traffic would be, and I would buy too much hardware, my CFO would be really unhappy. If I didn't buy enough hardware, our customers would be happy, unhappy. Yeah? And as such, there was always this careful balance. And especially when you hit towards what's called Black Friday. So there's that day in the US, like about a month ahead of Christmas, when people start buying all their Christmas presents. And so Black Friday often has 4 to 5 times the traffic of the normal week. So you need to buy a lot of capacity ahead of time. You can't just go one day before that to the local server shop and get 10,000 servers and roll them into your data center. That doesn't work like that. But what did happen always was that a few days just before Black Friday, a team would come up and say, oh, we've got a brilliant new idea. Yeah? If we do this, we'll make $20 million free cash flow if we do this. And I go like, but you know, I didn't plan for capacity for this. But in some way, he didn't say no. In some way, we always made it work. Because the constraints you have, the fixed amount of capacity that you could use, breed creativity. And if there is something that we as engineers are really, really good in, is being creative. We have the most creative jobs in the world. Believe me, everybody thinks an engineer, boring, you know, sits in her or his room upstairs playing games. No, no, no. No, we can go to work every morning and create something new. Who else can do that? Nobody. And so as such, engineers have an amazing profession. And in this world of constraints, you know, we are always making it work because we're really smart. Our heads are really good. No AI will ever be able to be as creative as that we are. Now, when we introduce cloud, it means that those constraints disappeared. Because now suddenly you could have as much capacity as you wanted. Yeah? Or if at the last moment you came up with a new idea, you could implement it because there was enough capacity, you could just get capacity on your fingertips. Yeah? And what happened is that everybody wanted to move fast. Everybody wanted to be competitive. Everybody think about innovation. You know, all the things that you couldn't do because you were constrained by hardware before that. And so those constraints breed creativity, and we lost that creativity. Went from being really frugal and making sure you could work within the constraint to, you know, move as fast as that you can. But, you know, we lost some of that creativity because we were no longer constrained. Now, in 2012, we did our first big user conference, reInvent, in Las Vegas. And I gave this presentation there with what I thought was sort of the 10, 12 sort of really big ideas that I would give you if you would develop on the cloud. Because I thought developing in the cloud was going to be radically different in the way that we had built software before. Yeah, now suddenly all these small building blocks that you could use, all these different databases that you could make your choice from instead of only having a relational one. And so I gave a whole list of things that I thought were going to be important. And most of our customers followed that advice. Yeah, if you have the production system, you launch at least in 2 availability zones, so it's highly available. Things like that, all of it. That's great. One thing everybody ignored, and that was the advice to architect with cost in mind. Because now suddenly, the world was different. Yeah, now you had to pay for each resource that you used. Remember when I had to buy hardware for my data centers, you pay up front. Yeah, and then you buy things and bring capacity in. Now in the cloud, things were different because you had to you could actually take cost into account when you were building your architecture. And so, you know, actually people ignored that advice because it was much more important to move fast, to innovate, to build these brilliant new systems. And remember, there's so many companies built and born in the cloud that are household names today. Spotify, you know, Uber, Airbnb, Dropbox, name all of them. All of these big startups that are now household names wouldn't have been able to do the innovation they wanted to if they hadn't been cloud. And so I put down, so given that I thought everybody sort of ignored that lesson, so I put down 7 lessons that I've learned at Amazon in the retail business, especially about sort of how to still architect with cost in mind. Because after all, cost is important. So I think the sort put them in 3 different buckets. One of them is design. You have to take cost in consideration upfront. Costs need to be what's called a non-functional requirement. Yeah? Functional requirements are the ones that sort of define the product that you build. But there's a whole series of non-functional requirements that you also need to take into account when you're building your systems. Yeah? Things like security, compliance, you know, but also my performance, what kind of availability do I want? Some of those are non-negotiable. Yeah? You can't have just a little bit security. You're either secure or you're not. Yeah? So those are, and you either need to be, you're either compliant with regulations or you're not. So those are non-negotiable. I think cost is also one of those non-functional requirements, but it's a negotiable one. It's one where you think about what kind of performance do I want at what cost? How available does this system need to be at what cost? How scalable? How maintainable? All of these are things that you can trade off against cost, but only if you take cost into account when you begin building your systems. And so things became easier in all of this because AWS has a radical different economic model than all the IT systems before. And if I'm thinking about how proud we are at AWS, and we've built some amazing technologies, innovated things, built databases nobody else had built before. But one of the things that I'm most proud of is that we killed the whole IT business from upfront payment. As a CTO, if I needed to buy, have a new contract for example, relational databases, the only way to drive my costs down was to make a very long-term contract, 5 years ahead of time. At Amazon, I had no idea how many databases I would need 5 years from now. So we would massively overscale, because they will come on premise and then see how many of these databases are you actually using. And if you're using too many, you will get penalized. And there was something else as well. For these databases, this 5-year contract ahead of time, I needed to pay ahead of time. So I would write this $1 million check to this database company, and then they didn't care anymore because I had been paid anyway. Yeah? They were not, I as a customer felt I was never in charge. It was always the vendor that was in charge. And so when we started AWS, we wanted to break that. Remember, Amazon as the retailer, or as Amazon as a company, has as the motto to be the Earth's most customer-centric company. So when we started AWS, we started thinking about what would be the Earth's most customer-centric IT provider. We do that by giving control to our customers instead of to us as the vendor. Yeah? And so pay-as-you-go pricing means that you pay exactly for each of the resources that you've used. And that means that when you are architecting, you can easily take that into account. If you want a bigger EC2 instance for this particular way because you need more memory, you know how much that's going to cost you. These were things that you could never do before because it never impacted the way that you architected your systems because you had to pay up front before you'd done anything. We try to be at AWS what we call cost following, meaning that the cost that we have, the pricing scheme for you is related to how much we have to pay for the resources. Now, I think our pricing model is pretty clear in that sense. However, when we started off, we did make a mistake in that. When we launched S3, we launched with a pricing scheme that only charged you for storage and bandwidth. Well, that's obvious. Yeah, that seems like the two things, the two big resources that are part of a storage system. Turned out, first customers there stored thumbnails of products that were being sold on eBay. And he literally had millions and millions of them. And as such, but in total, these thumbnails were really small. Yeah, so storage wasn't that much. Bandwidth wasn't that terribly much. However, he was doing millions and millions of requests a second. And it realized us that one of the other costs that we were having was actually requests per second. It's the only time that we changed our pricing model. Because we had to learn from this as well. Remember, this was the first service we launched. It's the only time we changed our pricing model, something else, which is requests per second. When we launched DynamoDB, for example, is a good example, we already figured that one out. Yeah? DynamoDB, you replicate over at least 3 different data stores. And as such, if you want to do an eventual consistent read, you only need to read from one of those stores. So it's one read operation. And as such, it costs you only 1 unit. If you want a strong consistency, you have to read from 2 of the data stores, which means you have to do twice the work. You pay twice the price. Yeah? And so by that, you figure that one out. Also see, we also have a number of customers that are extremely interested in for a different reason. Namely, there is actually the amount of resources used is sort of reflected in the cost that you have. It is also reflecting in the amount of energy that you've used. Yeah, so we I don't know if you know them, they're an organization, very large files. You can upload them, they upload them to S3, check them for viruses and compress them and things like that, and then people can download whoever has a link to it. They're also a certified B Corp. That means that they have very strict rules and regulations around sustainability. And why are they so keen on working with AWS? Is because cost is a very close proxy. Sustainability. Yeah, the higher your bill, the more resources you've used, the more milligrams CO2 probably you've produced. And so for many of our customers, cost is important, but sustainability is equally important. Yeah, so if I think about taking cost as a non-functional requirement, sustainability should that be as well. I mean, after all, we don't want to build beautiful digital systems and ruin the planet at the same time. Yeah, that doesn't really sound that terribly good. So, if I think sort of what sort of advice I'd give you when you want to build your digital systems, you have to consider cost at every step of the way. Every time you do a re-architecture, every time you make a decision, you should keep in mind, how much is this actually going to cost me? And maybe influence your architecture in that way. Now, another thing that I think is really important is that you think about, you don't build technology in a vacuum. You build technology for your business, for your customers, and as such, you have to think about your business when you think about architecture. It's not about, oh, we want to build this. Now, go off, build it, and then come back to the business and show, this is what we've built for you. In general, that doesn't work out too well. Yeah? You have to think about, if you're a young business, you have to think about over what dimension am I actually going to get my revenue? Yeah, if you actually have a revenue going over this dimension, but your costs are going over that dimension, you have no control over that. Yeah? Cost, think about systems and how to implement cost controls. You need to do this with keeping in mind over which dimension are you actually going to make money. And if you do that right, you can make use of economies of scale. Yeah, if you architect it right, the more traffic you get, the lower your cost per unit should be. That's what economies of scale basically tell you. Now, this is an example of a company that in my younger days I invested in. Turned out they weren't so successful. Or this is in the days, you know, we didn't have these MiFi devices yet. They were one of the first that did that. So basically they will connect to the telco network and give you a Wi-Fi signal. And every time, you know, whenever someone had used up their data, they needed to buy a new data package. It was great. Company worked perfectly fine. Yeah? And at some moment, their customers started to ask, you know, I find it really annoying that I have to rebuy every time these 10 gig. Can't you give us an unlimited data plan? Yeah? Sounds great. You can make it really expensive. Okay, said the company. We'll give you an unlimited data plan and make it really expensive. What do customers do with that plan? Watch Netflix 24/7. Yeah? Pretty quickly, the amount of data being used by these customers far outreaches the cost, actually how they've paid. So here, there is a disconnect between the cost that you have as a company versus the revenue that you're making. The company went bankrupt because of this. Yeah? Because you actually have to be really careful what your payment or what your strategy is for income, for revenue, and over which dimension your costs are going to increase. Now, if you think about sort of flywheel from Amazon.com, I won't spend that very much time on it, but you have to think about, you know, how can we accelerate what we do? This is the reason why you see this drawing is that this is what Jeff Bezos did on a napkin as sort of his business model before he started Amazon. The most important thing for retail customers is selection, which means the number of products in the catalog. The more products in the catalog, the likelihood is that customers can find what they're looking for. So they will drive more traffic to the site. Customers are happy because they find what they're looking for, drives more traffic, and that means that more sellers are willing to sell on the site. Now, last Q4, at Christmas time, more than 60% of the units shipped on Amazon were third-party products. And I remember our own sellers that sold on Amazon, they were angry about this. Why do we invite third parties to sell on our platform? It's ours. Well, it turned out that inviting sellers onto the platform was the best way to grow your catalog. So a new seller would come on board and would maybe bring 10,000 new products with him. That's great for our customers. So you get a flywheel. Yeah? This accelerates itself. If that's the case, you can lower your cost, economies of scale, and instead of pocketing that money, what you do is you lower your pricing, which becomes then another flywheel, because everybody loves low pricing. Nobody says in 10 years from now, oh, I love Amazon, I wish they were more expensive. Yeah? Not happening. Yeah? Another flywheel. You have to think about then, how are costs related to this? If this is my business model, where can costs grow? The catalog, for example. Everything that helps grow the catalog, you know, will drive your traffic. So if you think about architectures, don't think about architectures in a vacuum. Yeah? It's not just that you do technology decisions and leave the business out of it. The business needs to be involved in how you architect your systems. You have to also pay off your debts. You know, sometimes you know up front that technical decisions that you may need to revisit later, maybe just for the speed of execution. Yeah? For example, when we started doing Amazon Fresh, We did this on Ruby on Rails. Why? Because it's really easy to innovate with new interfaces, do the rapid prototype development on Ruby on Rails. But you know that as soon as you figured out how this is going to look like for your customers, you will need to rebuild it into something else that costs a lot less energy. Because Ruby on Rails may be a perfect prototyping and builder environment. It is quite heavyweight. And as such, it costs a lot of money. But that's fine for a certain period of time. But you do need to pay off that debt. After all, we all pay off a debt. I mean, you don't go to the bank and have a loan and not pay it off. Or a mortgage. The bank will come to you. Yeah? Now, in technology, there is no bank that will come for you. But eventually, the person in charge of finances in your company will come to you and say, why are you spending all that money? Yeah? What is the return on that? I always think that architecting, there is no one architecture kind of approach. There's not one approach that you can take. There's always a trade-off that you need to do as engineers. Yeah? And part of that should be cost. You have to think about, some of these things, as I said, are non-negotiable in my eyes. Accessibility, compliance, security, non-negotiable. You can't trade them off against anyone. If you do that, you have a faulty business. But, how reliable does it need to be? Does everything needs to be 4 nines available? Yeah? And so these trade-offs continuously happen when you start architecting. But this is something you have to keep in mind. You have to keep cost in mind. What performance can I achieve at what cost? Yeah? And really think about sort of these scenarios. If you have a median latency of 1.2 seconds of a web page to your customers, what does that tell you? Nothing. It tells you that 50% of your customers is having a worse experience. You need to know how much worse. And then you need to engineer at that what we call the 99.9 percentile. And then bring that in. But you improve your median latency. At what cost? Yeah? Those are decisions that you can make. And maybe there's a point of diminishing return there. Now, in all of this, you have to keep in mind that your systems are not going to be static. The systems that you build today probably doesn't look the same as the one that you will be running 2, 3, 4 years from now. Yeah? So keep in mind that things are not static. It's not only that you have to take cost in mind up front, every time we consider it. Yeah? Now, if you've built evolvable systems, it makes it easier for you to sort of add new pieces to your system without impacting the old pieces. Amazon S3 started with 6 microservices. Now there are 256 of them. Yeah? We always make a bit of a joke, like Amazon S3 started off as a single-engine Cessna plane, and we moved customers over to 777, and now it's a whole fleet of Airbus 380s. We moved customers over from one airplane to another airplane, refueling in midair, without customers ever noticing. Have you noticed that we don't have a maintenance window in S3? Yeah? Imagine that we send an email to all our customers saying, like, on Friday evening between 8 and 12, we'll take S3 down for an upgrade. I mean, so half the world comes to a standstill. Can't have that. Yeah? So, then in S3, one of the things that is very high, of course, next to sort of, we promise to keep your data exactly in the format forever, availability and reliability play an increasingly important role, as well as how to maintain this system while we are upgrading it. And you are not noticing anything. Yeah? Evolvable systems help you with that. So with these trade-offs, you have to figure out, what are my priorities? What is most important to me? Is performance more important? Or maybe I want to be really frugal and actually do it at minimum cost. That has impact on the others. Now, this is one of my favorite ones, actually, that if you don't know about your cost, you can't do anything about it. So you have to make cost explicit. You have to be able to see it. And the best way to actually tell you is a story about my hometown. Sunday just to save oil.
There was an oil crisis in Western Europe. I don't know if you know this, of the hijackings of the airplanes and things like that. Really lots of bad stuff going on. We had carless Sundays. You're not allowed to drive a car on Sunday just to save oil. But we also...
You know what the difference was between those two houses? The one that used 50% more energy had an energy meter in the basement. The one that used less energy had a meter in the hallway. That meant that every time you entered the house, you basically saw what your energy usage was. That impacts behavior. Because you suddenly are aware of it. If you hide it in the basement, it doesn't impact, it doesn't change anything that you're doing. Now, if you think about Amazon.com in terms of sort of how we do measurements there, you know, we really have to think about not only about one web page, we think about the small details on each of those web pages. This is an image of all the microservices that make up Amazon.com. Each of those dots is a microservice. The yellow thing that you see fan out there is basically what microservices get used whenever one of the pages hits. Sorry. So you have to know what your costs are per request. And then you have to, it could be cost per request, it could be transitive, that means the whole page is built up out of a whole set of components. What is that? Or, of course, you have to see what kind, after all, we were in a business, we need to understand what the conversion is per request. Yeah? If web pages go much faster, does the conversion improve? Those are kind of things that you really have to measure. And you also have to measure and think about new features. You know, ideally, you know, if you introduce new features, it has a good impact on conversion. But it may actually be that when you measure it, you see that actually it's tailing off. So there is a diminishing return on your investment there. Important in all of this is that you do have an A/B testing environment. An environment in which you can test new features and see what the impact is, also on cost. Nubank is a very interesting customer of ours in Brazil, and I have put this up because these guys are really moving fast, building all sorts of new digital technologies. Also, they have introduced a complete new protocol by the Brazilian Central Bank where every transaction needs to be completed within 10 minutes. Yeah? So everything changed. They had to build all sorts of new systems. But what they did is that every team has a cost champion. This doesn't mean it's only responsible for cost, but whenever you have an architectural discussion, this person is going to ask, how much is that going to cost us? If we make this decision versus that decision, which is important. Yeah? Now, for you, I think it's really important for everyone to have this meter somewhere, to see what your costs are. Yeah? Remember that maybe before cloud, if you would be a developer, you would have this server sitting on your desktop, and when you would go home at night, you would just leave it running. Who cares? You paid for it anyway. Yeah? In AWS, if you leave your development environment running at night, so you that shows you what your costs are for your development environments that you're running. And you know what the fun thing is? If you switch it off and you see the amount going down, that's pretty motivating. Yeah? After all, you can switch off your development environment. So let's do that. Go home at night. Now, if you want to build these architectures that need to be aware of cost, you have to give controls. You have to have some controls over it. And I think that controls that you have to do in collaboration with the business. Yeah? Your architecture needs to be tunable over time, because, I don't know, ever built something for someone, you know that they sometimes change their mind in terms of that may have impact on your architecture. Yeah? Now, very important in all of that is that whatever system you build, smaller building blocks, where each of the building blocks that you have a particular requirement. Yeah? Let me give you an example again of Amazon.com. We've divided all the components that we have in different tiers. Tier 1 are the components, because without that, we don't have a business. Search, shopping cart, checkout, reviews. Reviews are offline, people don't buy anything. Yeah, so that's tier 1. They always need to work. Tier 2, those components that are really important to our customers, but they can kind of live without for a moment. Recommendations, similarities, customers who bought X also bought Y, things like that. And then tier 3 are the nice to have ones. Yeah? If those are offline, nobody, for a little while, nobody really cares. Bestseller lists, for example. Yeah? Nobody will go and say, where's the bestseller list? Yeah? No. So if the center would fail where this service lives in, you can do a manual failover that may take 10 minutes or half an hour towards the other system. So you can have different requirements there. This is important. Yeah? This is your system, such that you can also have a conversation with business about how reliable does this need to be. And you have lots of mechanisms there that you can use as a technologist. Yeah? But most importantly, this is a conversation that you need to have with the business. What are the tiers? What are the most important components in this system that absolutely need to be replicated over 3 different data centers? Or 3 AZ? Which one over 2? And which one can only live in 1? But it's the business that needs to decide this. Us as technologists basically need to give the business the controls to use this. Now you can still babysit them while they're doing that and give them advice, but it's a business decision whether or not to turn decisions. You suddenly become incredibly lists of take it offline so that you have more capacity available for the things that really matter to you. So think about what are the tiers in your application? What are the requirements for each of those? That's really important. Now, and if you think about optimization, it's not only that you start, of course, up front. Many of us are running systems that have been running for years. And so optimization and cost control is something you have to do continuously. It's a continuous thing. Yeah? And you can stop some pieces if you think that the business is not worth it. Yeah? Think about sort of moving from, let's say, Intel-based architectures to Gravitons, which are ARM-based processors, may actually reduce your cost instantly by 30%. Yeah? Those are decisions that you can make. And we have got lots of tools, of course, in the standard. Then we have got all these profiling tools, and I'm very happy to have an audience. Be scared when I put some code on the screen in a minute. Yeah? So this is one of the apps that we had. And when we profiled it, we were blown away by the fact that 40% networking. Really figure out what it is. And so we looked at the code, and there was one perfect line of code. The line on top says, if a package is coming in, you need to parse it. If it doesn't meet certain conditions, you throw an exception. And the expectation was that only 0.1% would be exceptions, because exceptions are really expensive in programming. Turns out 90% of the packages meet the exception condition. So it's throwing exceptions the whole time. Just changing that from an exception handler to just an if-then-else statement, reduce the cost of that from 40% of the overall cost to 30%. Yeah? Just thinking about continuously revisiting your architecture is kind of important. Yeah? WeTransfer, the company I talked about earlier, in the earliest days, they really, I don't know what, I'm going to do something about this, sorry. improving, is it? Okay, well. We transfer in early days, so remember, upload something, their customers download it, and then they built in a safety period. Because after that, customers could delete the file they had. But it was always back and say like, oh, that wasn't, yeah? And so they had some line in the code there. It says, even if the customer said they deleted it, we'll keep it around for 7 days and then delete it. Yeah? That was hard-coded because it seemed like a really good idea. 5 years later, nobody knows about this anymore. Until they do a deep dive on their code and figure out, why do we have all the objects that are laying around that have been deleted? And so changing that one line, 7 days to 2 days, immediately reduced their storage bill by 15%. Yeah? These are the things. Revisit decisions that you've made in the past. It's continuous. And then there is this one thing that I think is more important today than any time in the past. You know, one of the first programmers was actually Grace Hopper, a very famous lady that actually had a significant impact on how systems are being built today. And she has this phrase, has this saying that the most dangerous phrase in the English language is, we've always done it like this. Yeah? For us as developers, that is, we're a Java shop. That's how we build systems. Oh, you know, we're really good at Rails. And as such, Rails become the hammer with which you attack everything. Or, oh yeah, last year we built something like this. Let's do it the same again. Now, you have to think about something here. You think about cost. The cost to build something is probably minuscule to the cost that it will take to run your system. Because maybe it takes you half a year to build something. Maybe you use Amazon Q or some other AI thing, and then it takes you 5 days to build something. But hopefully you'll be running it for 5 years. That's 5 years are going to be way more costly than the 5 days it took you to build this. So thinking about the infrastructure that you run, operational perspective, is absolutely essential. Yeah? And especially, I think, if you're also interested in sustainability. So lower your cost is when you as well. And specifically, this is the case with programming languages. When I went to school, I learned COBOL, IPL, none of these languages are used. You know, when we learn, you have to be ready to learn the programming language as well. Now probably, I don't know what you learn in school, Python, probably, maybe some Java, things like that. But you have to remember that if you look at programming language, is the efficiency, which on AWS is the proxy for cost. It turns out that some programming languages are hundreds of times more expensive in terms of energy and resource usage than others. Ruby, Python, Java, not terribly much. If you take the base is C, C++, and Rust. Yeah? If you go from Python to Rust, suddenly your system is 75 times as efficient as previous ones. And remember, Rust has premium security features. If you want to become a systems programmer over time, I really urge you to invest some time in languages like Rust. Because it will help your systems become more efficient and more secure. We are rebuilding, continuously rebuilding very large parts of AWS in Rust. Two of the senior principal engineers recently wrote a blog post on my blog all things distributed, where they go into the details of why they chose Rust over Java, because Java was a standard programming language. Now, a garbage collector. That means that you see bimodal, this is the performance, and then you have a long tail, and boom, yeah? There's a performance peak or a performance hampering peak there as well. That's just because garbage collection is running. Now, if you want to build a database system, yeah, you can't have tail latencies. Because actually 10% of all your transactions have a complete latency, the majority. Rust will take away all of that. Now, this confirm really, always challenge you. Yeah? Is there something new that I should be focusing on? Is there a new programming language? Am I as efficient as I do? Just because I'm really good at Java doesn't mean you have to program the rest of your life in Java. By the way, you won't. Yeah? Because when I go to school, none of the programming languages are used anymore. When you get to my age and you'll still be an engineer, yeah, you'll be programming in something completely different. So you will always be learning. So those are the six, 7 lessons. And there's something else I think that probably today, and especially comes to this large part of disconfirm your beliefs, that I think is really important. You know, nobody that went to school today comes out of university knowing everything about generative AI. That's something that just showed up around the corner, suddenly, from a commercial perspective. By the way, if you want to learn more about all these lessons and things like that, there's a website called the Frugal Architect. There's podcasts in there with other organizations about how they implement cost control and things like that. But when I think about generative AI, this is something you have to keep in mind. Don't let the media decide your architecture. The media is interested in the next quick thing, or in a negative story, or things like that. When was the last time you saw a media headline that says, this works really well? It never happens, you know. It doesn't work well is probably a headline you'll see all the time. But then, you know, make sure that you make up your own mind. Experiment, measure, learn about things that you don't know about yet. The term artificial intelligence was coined at a workshop in Dartmouth in 1956, yeah, by two famous researchers, Minsky and McCarthy. McCarthy later made this statement: as soon as it works, we don't call it AI anymore. Yeah? I always think whether you can turn it around. Yeah? If it doesn't work, we call it AI.
That's not really true, of course.
So, but what is most important there is that we had 50 years of artificial intelligence before Gen AI came around the corner. Amazing systems have been built with that. We just didn't call it AI anymore. We call it image recognition, natural language processing, we call it forecasting, we call it, give it all sorts of different names, except artificial intelligence. Yeah, and all these tools at AWS, like recognition, are premium tools to build systems with. And if you think, for example, an area on this in healthcare, if you look at what has been built in the past years in terms of healthcare, using old-style AI, it'll be quite spectacular. This university in Sweden there's a program, a public health program, where women over 50 can get a mammogram every 2 years to look for early detection of breast cancer. But the radiologist that looks at these images looks at thousands of images a day. At the end of the day, his eyes aren't that good anymore. Good as two radiologists independently looking at images. Being born with birth defects in their brain that are never being tested for. When the baby is being born, we test for their eyes and their ears and things like that, but we don't test whether they may have any form of brain damage. So there's a young business in Ireland that built this little cap that you can a minute or two and determine whether they may have some form of brain damage. Again, just making use of normal signals that are coming from the And this has nothing to do with generative AI. And there's a great system built here in Kenya, for example, for pregnant women. If they want to get advice about sort of their pregnancy, these guys have built a local that is targeted, that has all the knowledge about an SMS message to them describing sort of the thing they have or problem that they're having. The system will answer that back. None of this has to do with generative AI. Now remember, there's versions of AI that use in your systems that work really, really well. Also the underlying technology change we had, we had deep learning, and then, then we got reinforcement learning and things which work really well. Because remember, if you have an autonomous car, you don't want generative AI to be the autonomous driver, because it will make up a road over here that doesn't exist. Yeah? That's a risk you don't want to take. However, we have autonomous driving systems that work really well. We have drones that work really well. They fly autonomously to somewhere. Avoid birds, avoid dogs on the ground and things like that. So, keep in mind that, we still need to educate ourselves what are really the risks and the benefits of generative AI. This goes back to the early days of when we introduced technology. This is the famous curve of what's called crossing the chasm. And what that means is that, you build some technology in the lab, you got some early adopters, and then you start educating the rest of the world about the amazing technology that you built, and you get some of the early majority that starts using it. Generative AI skipped all of that. Didn't educate anybody. A year and a half, 2 years ago, someone just dropped this technology in the lap of everyone, including consumers, without education. Without saying, this is what it can do, and this is what it can't. Yeah? And there's also knee-jerk reactions there. Yeah, you get, especially these days when politicians are becoming more and more protectionist, everybody needs to have an AI act. Yeah? This is what you can do, can't do. But then every week, 5 new models are coming out, or 10 new models. Yeah? The offering is for most people, especially if you keep paying attention to the media. So our task as AWS is to get you to use as much as possible. Our task as AWS is to be your trusted advisor. Where does this technology work well, and where doesn't this technology work well? So Bedrock, what we've built, is the place for you to experiment, to try and say like, okay, this is the system I want to build with you, or this is the small application I want to build with generative AI. Should I use the very expensive 1 trillion parameter model, or maybe this small 7 billion parameter model is more efficient? Remember that this really big model will cost you $15 per million tokens, and the other one 15 cents. So if you build your systems, don't immediately say, oh, the media said this is the biggest and the fastest, and it can now also reason, it can do all those things, so we need to use that. No, each application, each vertical, each type of system that you want to build will have different requirements, and as such you may want to use a different model for that. So go play around with that. Experiment. Yeah? And one thing also, which I think is one of my pet peeves as well, is that most of the models that we're looking at, and the biggest in the world, and things like that, they're all US and Western Europe centric. Yes, you can access it in a different language, but what happens? It goes from Swahili to English, run the query, get English back, translate it into Swahili. This means you still get an English answer. You get an English cultural answer. There's so much more in language than just words. Culture is embedded in your language. And as such, don't shy away from using these big American models, and maybe start looking at some of these models that are more appropriate for your culture. And here in KLM, which is based on Swahili and a number of the other local languages, has that culture embedded in it. Or if you build a system maybe targeting the Arab market, you may want to use a different LLM or a Korean market or the Japanese market. Yeah, all of those have different cultures. And as such, you need to build your systems differently. In all of this, experiment. Experiment, measure, learn. Yeah? And cost should be a crucial part in this. What kind of quality of results am I getting for what cost? And that's crucial. I mean, in all of this, you know, our task is your trusted advisor. Is also to be your educator. Yeah? This is a quote that is really important. Yeah? There is no shortcut to experience. You have to do it. To experiment. You have to build it. You have to get your hands dirty on these systems so that you can talk to your colleagues at work or at the university or in your user group about these kind of things. Share your experiences. There's nothing more important than that. Yeah? You have to put the work in. And no matter how much all of these systems say, like, oh, programming, you know, nobody will be programming in the future. Oh, yes, you will. Believe me. Yeah? Now, there are a whole bunch of things that I love to not have to do. Going from 12 to Java 17 means not just sliding a new virtual machine, it actually means you have to change some code. And if you have 4,500 Java applications, it's a lot of work. And it's not very exciting work, is it? So, if you can have an automated tool do that, perfectly fine. Yeah? Oh, wait, you want to migrate from that mainframe over to Java over here? Let's help you with that. Nobody wants to do that work, believe me. Yeah? So, or, I don't know how it is with you, you know, whenever we get a new engineer on board in Amazon S3, it might take a year before that engineer is really a full-fledged contributor. So what happens? The junior engineer sits in front of, what is it, 1 billion lines of code and tries to understand them. Now, in general, there's a senior engineer sitting next to him explaining it. Yeah? But then, whenever you ask another stupid question, you notice that the engineer is getting a bit, not too happy, because he's got other things to do. Yeah? Now, if AI can help you with that, if Amazon Q can understand your complete code base and say, and this is why this is happening here, that's amazing. Who here wants to write test coverage? Well, not very happy, eh? Yeah? Nobody wants to write test coverage. Can automate that? Perfectly fine. And to be honest, I used to be one of what I would call cut and paste programmers. If I didn't know the answer to something, I would go into Stack Overflow, post a question, or look for the question, look for the best answer, copy and paste it into my code. Well, you know, if an AI system wants to do that for me, fine. Yeah? So all of these places. Now, imagine the AI system does that for you, and it's a piece of code that actually determines whether you're compliant with the regulator or not. Imagine it inserts something that makes you no longer compliant. So the regulator comes to you and says you're no longer compliant. There's no way you're going to say, oh, there's AI. I didn't do that. Yeah? Believe me, it is you using AI. The fact that you're using AI tools doesn't take away from your responsibility to know what you're doing, to know what the changes are that this system has made to your environment. Well, in all of that, we want to help you. Our goal is to democratize access to all of these systems to you so that you can experiment, so that you can build your knowledge. We also have this ML scholarship program, as well as a whole range of courses for free for you to follow. Take these, educate yourself, because only then can you make informed decisions. Because AI predicts, you make the decisions. You're still responsible for anything that your tools do for you. Now, one thing, and I said this at the beginning as well, one very important part in education is your partners, the people in the room here. And I think in Kenya, you have an amazing number of user groups here in Kenya. Work with them, work together, learn from each other. That's the most important thing. And also here, of course, at the university, the cloud clubs play an incredibly important role. So of all of that, I hope that you take the opportunity to learn from each other. To also learn from those in your community that know actually a bit more, that have been more active in all of that. I would like to invite Adeline to come on stage now. Come up, Adeline. As you know, there are some people that do more than others, in the community. Adeline, absolutely. So today, I would like to announce that the newest AWS hero go ahead. Adeline, we could not do this without you. And whether it is meetings like this, but the role you play in the community is crucial for all of us, not just first as a business, but to lift all the boats, to make sure that everybody has a chance to be successful in digital. And we are enormously grateful to you for doing that. Normally, I would give you a coin now for the hero. It's got stuck in customs. So that will arrive in a few weeks from now for you. But thank you very much for all the work that you've done in our community.